Bem-vindos to the Type Theory for All podcast. This is your host, Pedro Abreu, and in this episode, we have an awesome conversation with Alejandro Serrano Mena. He works on 47 Degrees and is a published author on 2 books about Haskell. Throughout this episode, we talk about many interesting features behind functional programming, such as adts, pattern matching, impredicativity, monads, effects, hacking the GHC, and how all of this comes together to grab industry attention to adapt functional programming features over the past decade. If any of this sounds remotely interesting to you, lean back, relax, and enjoy this episode. Let's get into it! Welcome to one more podcast. Today with me, I have the guest Alejandro Serrano Mena. Thank you so much for joining me today, man.
I'm happy to be here.
So Alejandro, he has done his PhD on error reporting in Haskell at Utrecht. He used to work as a professor there as well, but nowadays he's working on the 47 degrees. So I think we have a lot to talk about on Haskell, on his current work, and all of those cool stuff. But how about we start talking about, let's talk about basics of functional programming. Why do you think functional programming is cool? What are the things that it brings to the table for a software developer?
So I would say nowadays there are like two things that you can say about functional programming. It's what has already come and what I think it's gonna come. So I remember 10, 15 years ago when I was starting doing functional programming, people didn't even know what the map was. Like it's the very basic thing you used to learn when you're doing functional programming. You shouldn't iterate, you should use map to do your things. And I remember I found this like to be much nicer. This is when I was studying computer science. And I remember, this was, I had this group of friends which we like to look at crazy languages. That was our thing. So we went and go and learn Clojure and Haskell and Prolog and everything around there, just to know what was out there, because it seemed to us that the world couldn't end at C and Java, which is what they were teaching us. But nowadays, I mean, any language nowadays has a map. I mean, Java has map. Any new programming language, Kotlin, Swift, whatever you want, already has this thing. So I think this part, the part of using functions as arguments, values, like the core thing. I think it's there. It's now something people know, and I think it really shows that this was the right kind of way to look at those things, because people have found that, oh, now I can use the same idea, and suddenly you have all these streaming libraries which are using essentially the same concepts, and they can get they can leverage a lot of like performance out of this kind of more declarative way to do stuff. And then, as I was saying, there's like the second thing which I think it's gonna come, which is the approach many of us in the functional programming community have toward types. So more like the Haskell way of looking at types, this idea of having a strong types, and of modeling things kind of using algebraic data types, so to say. So you can see that some of them is coming to, like a Scala, for example. Scala 3 has it, and Swift calls it enum cluster or something like this, but that they are essentially algebraic data types. So I think the next thing that we are gonna bring from this kind of more Haskell-ish, or maybe more, is gonna be that thing, this the way in which we model data, and that thing. And I think that brings a lot of nice things to the table. I mean, it brings immutability, which is a good thing. It helps you not having side effects, which is something which people recognize it's good, even if they don't do functional programming. And at the end, it brings, like, well, the goal was always to have this more declarative approach to things. So this is the thing I expecting that comes, and then you know. it's this kind of good and bad thing. We would have won. Like FP is already here, and you can do it everywhere. So that's that's a nice thing, but it's no longer this small thing where we are doing in a corner, which somehow it's also cool and underground.
Yeah, no, yeah, I definitely agree. For example, you were talking about algebraic data types and how it's starting to you're starting to see them in more regular languages like Rust as well. Also is
Yeah,
also using ADTs, and I don't know. I just think the idea of pattern matching comes because you have algebraic data types, right? It just
yeah,
means that you can exactly look at your data and you know exactly what is in there and how things are going to behave and how are things typed, right? And then you can actually one very big and strong thing about pattern matching is that it's usually the case that it's exhaustive, right? It's not really the case for Haskell. Haskell allows you to have partial pattern match, which I don't know if I like it that much. But for example, OCaml,
I
you
don't. I
have
don't.
yeah. Thank you. It's really funny because I'm actually TAing a course this semester, and we're using Haskell. I think I haven't used Haskell for like 5 years now or something like that, and I've been just working with OCaml. And coming back to Haskell, I have there. It's so different, right? It's so different from the other languages, from OCaml, for example. Like they're very different from each other.
Yeah, to be honest, I haven't used OCaml other than to know a bit about it, but yeah, I think that what you're saying, like this kind of pattern matching approach to stuff, just gives you another way to write your program, which it's not actually related to function. It's like an orthogonal thing, but it's I'm nowadays used to think, and that's actually sometimes when I try to learn something new that goes in the middle, because for me it's okay. I have a piece of data. What do? I inspect it with a match. How do I do match
Yeah.
in this language? What do you mean you don't have a match? What do you mean? What do you mean? how do
What
i
do you
how,
mean this thing doesn't
how
have
do
a
I do
match?
list without like nil and cons? That's how you do list. Okay,
Exactly.
okay, you have, okay, at least you have maps. Okay, okay, okay,
We're
Java, I
getting
can work with
somewhere.
you.
Okay, yeah, we can work with maps. That's good. And with maps come folds as well. And folds is just it's just a way for you to iterate over your data, right?
Yeah, actually, I since I'm here in this public forum, I have a confession to do. Is that I'm really bad at doing folds. I'm,
Really?
I'm 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 terribly bad. I tend to write, so when I write things, and people are usually I have several colleagues which were getting more into Haskell or something, and they thought, okay, it's all maps and folds here, and then they see me writing a lot of recursive functions, which I
It's
know that
exactly
maybe
a
it's not the
fold.
right thing, but I'm really bad at folding, especially when I have like things where I need maybe to fold over something and accumulate something, and I know this should be a scan, but at the end I end up writing
The
the
recursion
the recursion with the,
explicitly.
yeah, my idea is always I will just refactor it, but if it's working, why would I change it? So I end up doing a lot of like, my style of writing has this actually a lot of more recursive functions than you will see in other people. Like, I really have a lot of if you, for example, look at the GHC compiler, they sometimes have this, that they have a go recursive, they have a recursive function which is local, and they always call it go, and then
Right, yeah,
at the end
yeah,
of the
yeah, yeah.
function is call go with the initial parameters. That's how I write code most of the time.
Wouldn't you say that's more like more continuation passing style kind of thing?
Well, I don't think it's continuation, but so something which I think it's nice about this Go pattern is that sometimes you usually, when you do this kind of recursion, you usually have like parameters which don't change, and then because it's a local function, you don't have to pass them explicitly, which is nice. Otherwise, you end up with very big. Uh, so it really, like, for me it really shows what thing you are doing the recursion over, and I think that is quite clear. But yeah, that would be the kind of same clarity you would get if you use map of forward. You are also very explicit on what you are recurring over. So
That's really cool. Yeah, no, yeah, that's a good thing. But you were also mentioning about strong static typing. Why do you think that's so good? What does strong static typing buys you in the real world?
Oh, I so how strong it is, I don't know. That's a question. I have also my opinions, but I think there is like um okay, let me see how can I phrase it. So there are many things which the compiler can check for us, and I think being able to leverage this, even if it's just this kind of uh very stupid things at the beginning, is like, is this an int or is this a person? Like being able to keep this apart is useful. So I think it's, why should you stop there? There is all this example where you can say, oh, I can give different types to IDs from this table, from IDs from this other table, and then the compiler will check for me that I'm not mixing them up, and that's a good thing, because, well, this is a problem which may end up biting you later, which you are just not having because all of this. And the same goes, for example, with having like an either type when when you can have an error in your function. Well, if you just like do the usual unchecked exception route, at any point you may have an error, but if you know that you may have an error here and you are forced by the compiler to handle this because this exhaustive pattern matching we were talking about before, this to me gives a lot of, it's not that, I don't think you have to put a lot of effort, so you don't necessarily need to go the whole GADT dependent types route, but there is a lot of things which, with many simple things on how you build your domain, that you won't make a stupid mistakes, which for me are the number one weird thing happening in your software, and what I think it's the worst kind of bugs to try to fix. Like, just spend a lot of time trying to figure out why something is wrong, and it turns out that you were passing the group ID where you were expecting a person ID because
Yeah, yeah.
whatever, and because you were doing Haskell, and they are called A and B because we cannot use variables longer than two characters. Uh, so so you end up missing the map. So maybe the strong typing in Haskell is just our way to be able to have small variable names, so we
Yeah,
cannot
yeah.
mix the map because of the strong
Right.
types.
Exactly. Exactly. Well, yeah, that's the thing. Like it's it's just an abstract type, but it must match, right? Like
Yeah.
if it's this A here, it must be this A over there as well. It doesn't matter what A we're talking about. So that's fine. That's fine. Right.
Yeah. So it's. I mean, I feel like this is one of these arguments, but it's very easy to go into extremes, like to say, oh, but if you do the full, as I was saying, dependent types thing, it's great, but then maybe your software is not maintainable, people have to learn about this. But it's like, no, you don't even have to go there, just stay on the place where we are fine, just normal types, new types, to differentiate those things. This already gives you a lot of things. And again, people is copying this. I mean, like value classes in Java, they are coming, or I don't know how they are calling it, which are just wrappers for the compiler but not for the actual runtime. These are new types. I mean, whatever you want to call them, it's this idea of, I just want to wrap something to be able to have different types, so I don't mix the map. But
Uh-huh.
once you are in the machine, use your fast integers, because that's only for compile time. I don't want to
I
create
see.
like a whole pointer or whatever
Right.
at runtime.
Just to make sure that they're different types as when
Yeah.
we're typing things. Yeah, that's a very powerful approach. I agree with you. Oh, yeah. Strong static typing is really nice because of that. It brings the failure too early, right? Like you won't even be able to compile the code because something was a little off over there, and if you couldn't match even that, how can you make sure that your program is gonna run as well? And one thing that you were thinking that I think one thing that when you were talking that we didn't mention is also with the power of ADTs, we lose the null pointer error reference, right? Like the $1 million bug on your like that. It's a huge problem. The null pointer reference, it's just everywhere and it's just so annoying. You have to check for your pointers everywhere. And with ADTs, you get rid of that exactly because you have to make sure that all your data is being treated properly, as you're saying. The errors are being handled
Yeah,
properly,
yeah.
right?
I mean, you can see like if you look at, for example, at Kotlin, they actually have a very kind of interesting design there. So they have a nullable type, so your type can be nullable, but it's actually your old pointer, your old thing, which can be null or not, but track in the type system. So if you interface with Java, for example, and your Java method says I'm returning a string, from the Kotlin side, you actually are having a nullable of a string because it might be null. And then because they are adding this kind of additional layer of type checking, you are forced to handle this. So you don't even have to add adts. I think it's actually a place where you can see that adding a type system can solve you a real problem, which is null pointers are a real problem. So we are going to add types which tracks whether your things are nullable or not. And well, they
Guarantee
don't
that
even
you're
have to introduce an additional type or
yeah,
whatever.
yeah. Just make sure that you're gonna treat them right.
Yeah,
Like if this is nullable, you must check if it's null or not and do
yeah.
something about it, right? Like don't throw me silent errors. Don't break me on runtime. That's the big thing about types, right? Don't break on me on runtime. So I heard that you also did some hacking on the GHC.
Yeah, that was when I was working towards my PhD. Actually, was working on two things. So my main goal of my research back then was to improve the error messages when you have you have a library, and then the problem with Haskell and in general with powerful type system is that, okay, you are leveraging all this incredible power of your types to write a library to know that everything is enforced. But when people use your library, then error messages tend to be big and scary. And actually, if uh, I hadn't tested this so much in practice before moving to industry, but actually, with a colleague of mine, we wrote a library. It's called Muse for microservices in Haskell, and we were using this. We had exactly this problem. We had strong types, very strong types. But then when people were trying to use our library, they were and they made a mistake, which eventually will come. The messages were impossible to understand. So the goal of my research was, okay, how can we somehow introduce hooks on the compiler so that when you are writing your library, you say, all right, when this thing is failing, please show this other message, which might be, it explains what's happening here. I don't know. My usual example was if you use, for example, the persistent library in Haskell, which is a database library. It uses a strong types for the kind of things that we were saying before, to have an identifier or something like this. But if you use it, suddenly you might get, uh, your type blah 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 is not an instance of key of, and you have a very big type, and what that means is essentially, oh, sorry, you are using a key from another table. And we know, and if you know the library, you know that what this means. And that's what, so why can't we make the compiler actually say this error? Like, you are selecting something of table group, but you are giving me a key of type person. That was my goal, to be able to have this thing. So that's I started hacking back then on this. I wrote a couple of prototypes, and then I tried to do it in the compiler. But actually, at some point, I derailed and I started working on impredicative types, which so it's
What
and that's
is
how I
what
did
is
my
that?
my I did most of my hacking on that. But so if you know, I don't know whether people is familiar with this thing called type error in GHC. It's essentially a way to say, for example, if you have an instance, uh, and this instance shouldn't exist, for example, like, oh, your functions shouldn't be EQ because you cannot compare them. Instead of not having the instance, you can write an instance which says type error, and then the compiler, when it tries to get this instance, will show the type error. Like, so you can somehow introduce a bit of this functionality I was mentioning. So I was trying to extend this to be able to say more things. So what happens if two types do not match? What happens if you cannot find an instance of this? So trying to do
Right.
these things. I didn't get that far, and actually, yeah, at some point it turned out not to be a great match to for GHC because of how how GHC has this kind of type checking which is non-deterministic, and what I was doing really required a deterministic way to look at your program, because otherwise you couldn't know when things will fire. So it turned out not to be a great match because of these two things. So this was just discarded. It's in some
Wait.
branch over there.
So is it the whole type checking that is non-deterministic, or is it the lookup for type classes
No, so
instances?
if roughly the type checker in GHC works on a high level. It goes through your program, and when okay, it parses it and then resolves every identifier. But if everything is resolved, then what it does, it's generate constraints. So it says, okay, because you are using this, this type should be equal to this type, and because this is calling this function, this type should be equal to int. And then there is a second phase, which is the time where these constraints are sort of solved. So you could imagine like you have a big system of equations, and then there is something which solves this thing, and the order in which this second thing works is non-deterministic. It because there it's uh imagine, for example, you're trying to resolve an instance, and your instance says that you need to, for this instance to hold, you need the instance for these other two type classes. So there is no guarantee that GHC will look up the first one first and the second one first. And
Hmm.
actually, it happens that sometimes the constraints are delayed because you don't have enough information to solve them yet. And then at some later point, when you have enough information, then this thing is taken out from the back of unsolved constraints. And all this process, I mean, of course there is an algorithm, but you cannot, it's essentially non-deterministic. You don't know at which order all these things will happen. And that was a bit against of what I was doing, because well, as I said, I had to be, for example, sure that there was no point in which this thing will later be solved. How do I know this if it's non-deterministic? Do I wait until the end? It didn't work
Line
so well.
up properly. Yeah,
Yeah.
yeah. But then you started working on in predictive types, you
In
said?
predicative types, yeah, this was
What
like
is that?
so the idea is more or less this thing. So so in Haskell and in many of these type system, we have we have polymorphic types. Like you can say that identity function has type for all a to a, right?
Yep.
Uh, but this is always at the layer of it's top, it's like top level. You have for all of some things, and then your type. So that's what we call a rank one polymorphic type. But you can also think about nesting things. So you could say, oh, this is for example, imagine you want to have uh, a function which operates both on an integer and a boolean, and then return whatever. You would need a function which has type for all a to int, for example. But this for all is now part of the argument type. So it's like the for all is inside. You need to give a polymorphic function as an argument. So it's not that you don't. It's no longer rank one because your for all is hidden inside one thing. And there are some uses of this. I don't know, there's some generic programming patterns you want to do with this. Or for example, the most practical use I know is that if you look at the lens library in Haskell, actually the type for a lens is one of these types with a for all inside. So when you combine two lenses, even you don't see it, the type lens SA is actually for all blah 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 to for all blah blah blah. So it's actually using what it's called rank n types. Um, so now, if so, that's like rank n type, but you can go one step farther, which is you want to be able to use for alls everywhere, like in a list of for all whatever, and that's the last step. That's in predicative type. So being more formal in predicative means that when you have a type variable, you can instantiate that type variable with a for all type. So for example, if you have like the type of head is for all A, list of A to A. So an impredicative instantiation means that, for example, I'm choosing this A to be yet another for all type. So you can use it on a list of for all BB to B, and will give you as a result a for all BB to B. So you can replace a type with yet a big for all, and that's what impredicative type is. Uh, but there is a problem when you have impredicative types, and that's the problem. So I started doing this because in order to do my research on these error messages, uh, for example, the type of a construct of like a JDT and some of those things involve this kind of type. So I wanted to formalize them to be able to say how, I was doing a pitch, so everything had to be very formal about like I am approaching this in this way. So I was formalizing this. And then if you see the flag in predicative types in GHC, it was always kind of, oh, don't use it, we don't guarantee that this will keep working. That was because in predicative type didn't have like a clear specification on about how they were working and so on. It was actually like, oh yeah, you can do this, but because of this non-determinism I was mentioning before, it could be that in the next version of GHC, in which constraints were solved in a different order, you could no longer use your thing in predicativity because it couldn't find it or whatever. So I ended up writing an email to Simon Peyton Jones, like I was young and full of dreams and whatever. And to my surprise, like 4 months later, like I had already like forgotten, like I had written this mail. I get a mail from him saying, "Oh, would you and your supervisor like to come to visit me in Cambridge?" And it's like, yes, yeah, like yes, right.
Yeah.
And it was even better because Microsoft Research was paying for the trip and all of that. It's like,
Oh my god.
yeah. I mean, it's also like I'm in the Netherlands and Cambridge
Right. It's
is
pretty
in the UK,
close.
so it was pretty
Yeah.
pretty nearby. But and we started working on this problem, and at the end, what we end up is with a solution to the following problem. The problem with impredicative types is that sometimes it's hard to choose whether you want to, like, imagine, for example, I have this thing about the for all I was mentioning. Sometimes it's hard to say. Imagine at the end of the day you want to use something with type int to int, right?
Right.
What am I gonna do if I have a head of a list? Am I going to replace my type in head with for all a to a to get then the first element, which is of type for all a to a, and then turn this for all into an int to int? That's one possibility. The other
Right.
one is that I directly use int to int in the type of head. This and they choose two possibilities give me a way to get at the end the function I want. So this is an ambiguity, and this is the heart. I would say the heart of the problem here within predicative types. Whereas with Haskell 98, Hindley Milner like type system, you have one choice, And that's what is so great about it, that we have this principal types property and everything has one choice to do. Here within predicative types, this breaks, and this is not the first time that this happens. Like GADTs, for example, also break this property. So they had this very big paper called Outsiding, where they explain the choices they make to no longer have this ambiguity, and why those are the good choices. So we did something like that, and we came with an algorithm. We call it quick look impredicativity, because the whole idea is that sometimes by having a quick look at your types, you can decide. Like, for example, if I have head, if I was saying I have head, and I don't know what to do. But right, if you are giving me a list of int to ints, I no longer have a choice. There is only one possibility. I need to choose to instantiate my A with this type. So the whole, I mean, it's a beautiful paper, but the whole idea is sometimes you don't have a choice. So let's just leverage this choice. If we have a choice, and we ended up having a theorem and a nice proof about when you don't have a choice and so on. And then when we don't know what to do, we just go back and say, I'm sorry, I don't know what to do. You tell me the type, or you either
Right,
tell me
right,
the
yeah.
type, or and
What
most
can
of
I
the
do?
time, there, to our surprise, this kind of naive thing was enough to handle every possible example we had. Like, every example where this failed, if you scratch the surface enough, there was actually an ambiguity. You may not have seen it beforehand, but there was actually an ambiguity there. So it seems that our algorithm worked well enough in practice, and that's why it made into GHC9. So I didn't write any, like, all I'm certainly that maybe one line of my original code still survives there, because uh, Simon rewrote it, and had to actually handle many cases that were not in the paper. But in GHC you have all these other extensions, things need to work with. So he just changed everything so many times that as I say, I'm pretty sure there is like one or two lines from what I wrote back then. But now I learned a lot about GHC, so that's good.
Yeah, that's super nice. I don't know anything about the GHC. Is it how can I give us a brief idea of how big the GHC is, or how hard it
Oh,
is for a starter, a beginner to start hacking on the GHC? What would
so
he
so
need?
the first thing is that GHC, it's just huge. It's incredibly huge. Actually has very long files. Like, files are often like thousands of lines of code. It's still pretty readable code. Um, I don't actually know a lot of the whole GHC, because the whole, like, if you think of a compiler, it really has a lot of things. Like, you have the parsing stage and the resolution stage, and the part with deals with figuring out where things are. So I was only concerning myself to the type checker, which is like it's a big piece, but it's in
It's
one
self-contained. Yeah.
yeah, it's in it used to be that the files were called tc blah blah blah, and you knew this was about the type checker. Now I think they changed this to actually having to be in folders. I guess there would be in some type checker folder. But then, like if you, I don't know, you can spend your entire time with only one of these phases. So you have the type checker, and then you have the thing which optimizes the code, and it turns it into this other thing called core, which is like a core language, which is also type inside the compiler. And optimizations happen there too. So there are so many layers uh, that, I don't know. For me, it was a bit hard. So first, I had to just have faith that the rest work, and just concern myself to the very very little that I had. So the nice thing is, because the type checker is actually a place where a lot of people do research, it was very well commented. So the GHC team has this very nice idea of having notes in the code. So they are like super big comments, but they are written, like, actually they sometimes even have examples and they explain you the algorithm or whatever when it's hard. So sometimes you have something weird here, and you find a C node there, and then you go and find the node. Uh, so and because this is also used by many people, there is a lot of options in the compiler to actually trace what is happening. So you can do something called dump tc trace, like dump type checker trace, and then you essentially have a trace of everything you want to do. And there is a lot of good integrated ways to actually include more things on the trace. So I could just do my stuff and add my own traces, and that would help me a lot. Of course, as program grew bigger, then this was harder to. But that's for a small example. You could very easily like dump your program with all the constraints and dump your program with the final result and when things failed and something like this. So this was very. But yeah, I would. So if somebody wants to look at this, I would actually suggest to not try to look at GHC as a big thing, because it's really really big, but just try to figure out what is the part I need to look at. And because it's kind of very well engineered, you can really concern yourself to, oh, I want to bring something new to the optimized rules. Well, you go to the file which does the optimized rules and understand this, and it's usually very well self-contained. So but
Yeah, yeah, no, yeah, that answers my question. That's nice. But yeah, that's the thing about starting to work on any, like used software, like any actual software. It takes time for you to get used to what's going on and understanding how, like the environment around this function is working. And it's just I always say that the first month of work, of like getting accustomed to the code base, is just always so painful because of that.
yeah,
Like
yeah.
everything feels so lost and it's so big in there. Of course, GHC is going to be that, but so much worse. It must be so
Yeah,
big things there.
I mean, I would say if you have, it's like usually if you have like your a specific use case, then
Yeah,
then I think it's easier because you can
much
try to
easier.
dig
Yep.
there, and then I don't know. For some people, I think it works better to go like from a general point of view. But for me, it works also in general in software, like to try to dig and see what my problem is happening, and then try to figure out what's around it, like the dependencies from the code more than the other way around. If you try to understand GHC as a whole, it's so big it doesn't fit in anybody's brain. I mean, maybe Sheldon Cooper's brain, but that's certainly not mine.
Yeah, 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 for sure, for sure. But yeah, talking about Haskell, the other amazing thing that Haskell has brought to the table was Monads, right? It was first created there, if I'm not mistaken. Maybe I'm seeing a major, but
I
Monads.
think I think so. I guess it was. I mean, Monad is this idea, which is, but it was brought. I think the main thing which Haskell brings to the table or brought to the table was like, oh, let's actually make Monad our core thing and build do notation in the language. I think that says. No, I mean it's not only about bringing the idea of monad, but actually thinking it's so important that we are gonna build syntactic sugar upon it. I mean, like Haskell has almost zero syntactic sugar if you think about it. It's all functions and pattern matching, but it has do
Yeah,
notation, which is
true.
kind of interesting that they made this choice.
So why do you think Monads is so important to Haskell? Why do you think they made this whole idea of programming with do notation around Monads? What's so nice about it?
Well, I think well, first of all, one thing that Haskell requires is it's monads for I/O, which is like very specific for the language. So actually,
Hmm.
when I was teaching functional programming as a lecturer, I often sort of introduce students to this impure part of Haskell with do notation, and never told them it was about monad. It was just about that's how you print things, and it makes sense. And
Right.
actually, if you think about it, it makes sense because if Haskell says that pure and impure is so important, well, how to make the distinction better than by actually introducing two different syntaxes for these things. So
Yeah, makes
people
sense.
went on with the lie for a month or so until I told them this is actually about monads. So that, like, for the, I mean, I actually mean, like for the midterm they thought like do notation was for IO, and then they discovered the truth. But apart from that, I think, like, it's one of those things which, I think it's just an abstraction which works pretty well in lots of cases. Like, I cannot really say why, but the fact that if you want to do validation, that's a monad, and the fact that if you want to do things with lists, that's a monad, and the fact that if you do something, like asynchronous programming, your async thing is also a monad. It's just, I don't know, it's like,
Things fall,
why is
right?
it,
Just
I don't know, it's about sequence, it's maybe
yes.
how we work. But for me, the I mean, the whole the whole thing about using monads, for me, at least when I do Haskell, when I do Scala or things like this, where you can do this, is that, you can just build this library. The fact that control.monad has, I don't know how many, 20 functions which work over any monad, and then you have control.monad.extra which has other 20 of them. It's just so great, because it means that you don't have to repeat things over and over. Like, I don't know, map m, this is an abstraction which keeps giving you things, like, it's like this thing where the answer is always traversed to any of your problems.
And you also have monad transformers as well, which means you
Yeah,
can combine those monads together, and then you get the power of both of them, and
yeah,
then keep
yeah.
going and growing. Yeah.
And you can think of effects, and at the end of the day they are not monad, but they end up being a monad, which has, it's not monad transformer, it's a different thing. But this idea of sequencing stuff appears in so many places that I think they were very good at recognizing this, and saying, well, we're gonna make this part of the language, because that means, for example, you look, going back to Kotlin or C sharp, they have this special question mark dot operator, which is like the flat map, sorry, the bind, for your maybe type, and they have this specific one for this. Or you go to JavaScript, and they have a special syntax for promises. They have this async await, but that's also flat map for promises. So I'm always amazed by how somebody look at all of that, and so, oh, this is all the same thing.
All the
If
same,
we have
exactly.
the do notation, we have an all notation for all these specific cases in C sharp, in JavaScript, and so on. So I don't know. It's so great that it works, and of course, once you see this, if you recognize this and learn to work with this, that means that a lot of problems which were hard, and I think a lot of problems that we do in software, it's essentially, oh, I have a list of optional things, and I need to apply an operation which works asynchronously. This is, it's a lot of boilerplate code, unless you figure out, wait, my list of optionals is traversable, and my thing I want to do is A to IOB. So I have a traversable thing and a thing which has side effects. Oh, my answer is now traverse. Just by
Yeah.
by 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 looking at those things. And this is, imagine writing a for loop to do this. Like, it's it and sync, I don't know, asynchronously or whatever. So that's why I think, like, having this toolbox gives you thing, because it makes some of the annoying parts of programming into, well, one higher order function.
That, yeah, instead of like solving the same things over and over again, and like it's error prone and whatever, you're just solving it once, and a lot falls from there,
Yeah,
right? Like, actually a lot behaves like that. And I think the one key idea is that more than we think, more are effects than we think, right? Like, monads are about effects, about modeling algebraic effects, I believe. So, like, actually, a lot more, affects a lot more than we expect, right? I think that's there.
Yeah, the intuition for effect is again something which could be so many things together. I, I for example, like the one thing which I pretty like, if you look at there is this library in Scala called Cats, and they also model monads and applicatives. They have this interesting idea, which is what they call the parallel. They have a type like called parallel, and that's this relates a monad thing and an applicative thing. In that the monadic thing is like the sequential version of an effect, and the applicative is the parallel version. For example, you have it if you have so in their library they have either, which is like fail first, and you have validation, and validation, which we also have it in Haskell in validated data type or something like this. It's one of those things where if you have several errors, you combine the errors. So you cannot have a monad instance because monad instance drops something, but you could have an applicative instance which combines the errors. And there is this interesting relation between either and validated. One is the sequential version of the other, or one is the parallel version of the other, and and they have the in their library for what they call IO and par IO, which in Haskell would be something like IO and async from the async library. Like if you have an IO thing, you can turn it into an async, and then things will create threads in parallel. Or if you need to do something sequentially in otherwise parallel computation, you have to go back to IO. So you have this relation to, and I think that that's also a pretty interesting combination because it shows you, for many people, applicative is just like a super class of monad, which gives you these nice fancy operators with the stars and dollars, and it's all symbols. But actually, they kind of show you the power of having an applicative without being a monad in this parallel type class. I don't know what. So yeah, and this was coming because of these effect things, and this is, I think, an interesting idea of saying there are effects, and some effects can be sequential or parallel in different ways. Like validation is one of those things. Like IO is another thing. They have more examples of this kind of two the same effect but look through different glasses.
Yeah, that's really cool. And I think you're actually nowadays you're working more on seeing how these things come together in different languages, right? Like, I mean, you used to work on Haskell, but now you're working. You said in Scala and Kotlin.
Yeah, so the company where I work on 47 degrees, they uh, do consultancy, and I'm mostly working on internal projects, but they mostly use Scala and Kotlin nowadays. So they know, like all the people around me just know too much about the JVM, like all the tiny
Wow.
bits, like this will overflow your stack. What is that? We don't have that in Haskell. Okay, now I have to learn about the stacks, but whatever. Uh, and it's interesting because they are all very they all like functional programming. Like if you go to our website and you go to the blog, everything is about functional programming. But of course, it's of a slight different thing because it needs to talk to Java things. And also, these languages, well, Scala is super powerful, but Kotlin, for example, doesn't allow you to have the notion of monad because it doesn't have, well, higher kind of types, like the ability to talk about m of something, but they still follow the same patterns, which I find quite interesting. So I'm learning a lot about how to bring this thing, and that's more or less what we were talking about. So things keep coming to these languages, and you can see that they are coming, and that's actually one of the biggest surprises for me, that I started, like helping some of my colleagues with some things, and I ended up like going full vested in Kotlin because I could just express everything I used to do in Haskell, but in Kotlin because I have ADTs. Again, they call it differently, but they are ADTs. They have higher order functions. They have flat maps for these things, even if they don't say this. And my colleagues have even built this library called Arrow, which is every functional nicety you are missing in Kotlin. They have implementing it. So it's kind of interesting to see it, how I can, I always thought if I ever want to apply all of these, I will have to go to one of these very few companies using Haskell. And it turns out that I can actually use the same ideas, just with a bit of different syntax. So I actually need
But
to use braces
that's
nowadays, which is not so bad given my fights with the layout syntax. I mean, I'm again, I must be the only Haskeller which doesn't use folds and loves braces, because oh my god, layout syntax is, it always bites, it always bites me. Like,
no, but I think these ideas that are coming. So yeah, I see functional programming languages as a big, I want to say a big laboratory, a big experimentation where we can try all the cool things that we want. We don't care that much about usability, especially in the old days, like when let's say Miranda was born. Like it was a big functional programming back then, right? Like, oh, maybe Miranda is not the best example, but anyways, yeah, I just broke my own argument, but
no, but you
uh,
can see, I don't know. For example, pattern matching is this thing where I think it's good that it's now coming, because now it's been refined and we know what works and what doesn't
yeah,
work.
yeah,
You have
exactly,
people
exactly.
experimenting in F sharp.
So
Okay, for example, F sharp maybe went a bit too far, and they have very weird patterns you can have. Like this pattern where you can pattern match. I think they have in Scala too, like in the tail of the list, but you pattern match in a
really,
different way or something like this.
wow,
It's kind of complicated, and I think I cannot. I think that might go too far, but
right.
yeah. Uh,
But that's what my point. My original point was that we have all these nice different ideas that we're not applying in an imperative language in the regular ways, and then we show that no, it's actually pretty usable and pretty cool. We can do very cool stuff with it. Look at Haskell. Look at all the cool stuff we can make with Haskell, and look at how simple these ideas can be expressed with monads, with maps, with flat maps, with folds, right? And then these other languages are like, oh, actually that's actually pretty cool. Let's bring it to our language. People started actually asking, the community is like, why don't we have this? Let's make this work, right? Like this is actually going to be really nice to Java. This is going to be really nice to Kotlin, right? And that's very powerful. That's very good. So that this is what you're saying, that you can actually do this functional style programming. I actually think it's kind of like pretty new, from maybe the last few decades. How old is Kotlin, for example? It's,
yeah,
oh
Golden is
my
maybe
god.
10 years old or something like this. So
Yeah, yeah.
I mean, yeah, and you have Swift, but that it's also pretty new. So, but yeah, new languages nowadays have it. Like you don't really, if you don't have it, then you are
Behind. Yeah, you're
yeah,
not
you are
cool. You're not with the
behind.
cool kids anymore. You
Yeah.
cannot come with us in the during lunch. You cannot eat with us. Go away. So what else? What other? You said that in 45 in 47
47.
degrees. Yeah, sorry about that. So you said that in 47 degrees you do a lot of consulting. What sort of projects do you guys look into? Why would a company come and hire 47 degrees?
I said I'm also on a kind of a different thing. I don't go with clients directly, so I'm
Uh-huh.
working on internal projects for the company.
Oh,
So
okay.
things which eventually will make the life of my colleagues better, hopefully. And I do training. So one of the things, for example, that a lot of people come to 47 degrees is, well, they are learning Kotlin, and they want to know how you can approach things in this other functional way to learn. So have
Ah, right, yeah.
a colleague of mine is very good at training this kind of at being a trainer on this, and a company comes, and well, sometimes we do it public. I've done a few courses in Haskell, like from zero to somehow being able to even use mono transformers in 1 week or something like this. And so yeah, I think like most of the people approaching us already have like a taste of the idea that functional programming can help them somehow. It's a good way to architect their things. So a lot of the people that company work with are using a Scala, and I think Scala it's also they have a part of the Scala community is very into pure functional programming. You have all these libraries from what it's called this type level organization, which is like CATS, and CATS that's for category theory. So they have functors and monads and so on. So they want to use this kind of things. So as a consultancy, you can help them by either training them or showing them or being in as part of their team how to leverage this kind of thing. So it's yeah. So it's like if you I think most people can, as I said, already have the idea that functional programming can help them, but sometimes it's also hard if you don't have an expert to imagine you have
True.
a team of engineers and you want to use these techniques and you want to use these libraries because they give you a nicer way of, at the end of the day it's always the same, it's a faster way to write software. Some Most of the time you need an expert to come and tell you, well, that's how you use it, you are doing it wrong, that you review your code. Oh, you should, I don't know, from small things like, oh, you're using flat map but you can do it with map or with a do notation here, why don't you try this or that, to bigger things is the kind of things which, so it's I mean that's also why I see like functional programming is kind of taking over the world, because I
Yes.
see all these companies which literally want to do functional programming in one way or another.
We don't care what we're gonna do with it. I want to do functional programming, and you guys are gonna help us.
Yeah, no, I mean, of course, like there are several places where this actually helps you a lot. So in the company, for example, there is also a lot of people which have a lot of knowledge about microservices. And if you think about the microservice architecture, that's actually pretty great for functional programming, because you have these self-contained components which cannot talk to other people. So it's not like you shouldn't use mutable state, is that you don't have it because your other microservice is in other part of the network. So you really, it's a really good place to actually have like a very functional core where everything is pure, plus a bunch of adapters to talk to things, which is actually like, if you think of Haskell, that's like type classes, like things for serialization and so on. That works so well. It's, I think people call it hexagonal architecture these days, but it's like you look at it and it's literally like put pure functions in your center, put a bunch of IOs with type classes around it, and deploy it as a microservice. That's like
Wow.
and
Wow.
you cannot get more functional than this. So,
Right.
so
It seems like
actually,
this is a problem created to be solved by functional
yeah,
programming
yeah, yeah. So
almost.
people may also, I don't know. I mean, as I say, I don't know how clients come to the company, but they might actually come to help with microservice architecture. And whoa, it turns out that you are doing functional programming. Who knew?
Well, that's really nice. That's amazing. I think we are starting to running out of our time.
Yeah, I have 10 more minutes or so.
Is there anything particular would you like to bring up that we didn't have the opportunity to touch in the episode?
One thing is that now it's been pretty nice for me to actually have a look outside. I would actually suggest people to do this more often. I was pretty excited in the last years. Like I was doing Haskell most of my time, and suddenly I found about Scala and Elixir, which is also like a great. It's also like another great language. People want to look how functional programming actually helps you. It's like if you do functional programming, you can actually get incredible performance in concurrent system, and Elixir is the proof of that. So it's like it's not just useful on the conceptual level, it's actually gives you a performance boost to do this. But I'm still like invested in the community. So I recently started a podcast with other people from the community. It's called the Haskell Interlude, like a word play with the prelude, and that's
Oh,
part
and
of this.
smart.
No, you might have heard about the Haskell Foundation, which is this new
Right.
foundation which is trying to push for more Haskell adoption. So as part of like let's say how you say outreach. I was gonna say marketing, but I think it's the nice word is
Yeah.
outreach.
Good job.
It's like you see, I'm learning. We are bringing it podcast, and we essentially talk to people which uh, are well known in the community, or actually we try to look for people which are you find people which nobody knows about, and suddenly they have like you find out that they have this incredible piece of software in an open source repository. It's like, please tell me about this. I want to know, like, how are you doing, I don't know, machine learning in Haskell? How can you do that? What things like that. Yes. And apart from that, well, I've been interested with for quite some time on people using this kind of more functional things. I've written a couple of books about Haskell back in the day when I didn't have two kids and I had time. now, now all my time is devoted for them to grow enough so I can teach them about monads. But they are a bit too small
How old
now.
are they?
They're 6 and 2, I think.
Yeah, they're a little too young. Maybe wait
Yeah,
two
yeah,
more
it's-
years for the 6-year-old,
Yes.
then he can learn some monads.
Yeah. They need to be exposed to promises and options, so they can generalize from the facts. That's
Oh
that's
yeah,
my goal.
yeah, good job. You're actually a pretty good teacher. Like building from small steps and from the easiest to the more complex things.
Yeah, I think I got it from somewhere. I think you know if you see nowadays, everybody who explained monads explained in this kind of from the concrete to the abstract, starting from a few examples, and I found that this actually works. But yeah, and soon, actually, speaking about monads, so I'm gonna I'm working on a second edition of the Book of Monads, which is the book I wrote about monads, with a fancy new cover and all of that, and hopefully in a nicer way. So just saying, this will happen. So if people are interested on monads, this is called the
Check it
Book of
out.
Monads. It's about monads.
Check it out, guys.
Yeah.
So make sure to check out his books on the Book of Monads, and also A Real World Guide to Programming is his other book.
Yeah, it's called Practical
Oh.
Haskell, I think.
What?
It's called, yeah, I think that was the subtitle or something like this.
Oh, I've got the subtitle of your book. I'm
Yeah.
so sorry. Let me do this again. So, hey guys, make sure to check out his two books, The Book of Monads and the
Practical Haskell. I know it's hard because people don't associate Haskell with practical, but believe me, that book tells you about how you write web services and stuff like that, and monad transformers, because you always end up using monad transformers for everything.
There you go. There you go. You're gonna learn everything you need about Haskell. If you thought this episode was anyhow interesting, if you wanna start hacking on the GHC, that's the way to start. You read the book and you're gonna be ready to go, right?
Yeah, of course, yes. You might also need to check, some other people who know about this, but they are actually nowadays. It's all. I want to say that the GHC team is doing a great job on bringing people up to speed. Like nowadays, there are a few people who devote a lot of time pair programming with people who are starting in GHC, which would have been awesome when I started.
Is it maintained by Microsoft Research?
No, it's like a separate thing.
Oh yeah, the own Haskell Foundation.
The Haskell Foundation is also
right.
different. So GHC is like its own team, and there is like a few people maintaining them, like a core team. Of course, I mean, Microsoft Research was paying the salary of Simon Peyton Jones, and like there are other consultancy like WellType and Twig are paying salaries of other people working part time. So you could say that it's like a community thing. So there's people at the end of the day working full time there. But as I said, nowadays, like if you want to know about how it works, I would say like Richard Eisenberg has a series of videos. Like he's literally just opening the GHC code base and fixing a bug. So yeah.
I'm gonna put that in the link of the description of the podcast to make sure that everyone can check that out. I'm actually that's really cool stuff. we're running out of time now. Thank you so much for coming and having this amazing conversation with me. It was a lot of fun.
Oh yeah, it was. We didn't even talk too much about impredicativity. I'm so.
I hope you guys enjoyed this episode as much as I did recording it. I sure learned a lot with Alejandro. Don't forget to follow him on Twitter at Trupill, TRUPILL. Also, I want to apologize for taking so long for posting this other episode. I was caught up in work submitting my first author paper. Hooray! And before that, I was having an amazing vacation in Brazil, visiting family, friends, making sure I take care of my mental health and whatnot. And I urge you, my dear listener, to also not forget taking good care of your mental health, okay? Sometimes it's really easy to get all caught up in work and lose perspective of what really matters. Anyways, enough of this. Let's wrap this up. If you guys have any questions or comments, feel free to post them in our website, www.typetheoryforall.com. I also have a brand new Twitter just for this show. Make sure to follow @TT4all so you don't lose any news about the upcoming episodes. And I think that's it for today. Stay safe, and I'll see you next time.